Hi, we're going to look at what happens when you react an acid chloride to a carbonyl bonded to a chlorine with an alcohol. Alright, so remember this is our electrophilic site, so we're going to do the chemistry at the base of the carbonyl. The oxygen is going to be our nucleophile, and we're going to exchange this alcohol for the chlorine. So let's look at the carbon chain. It stays the same. We're going to reform the carbonyl, because remember we're going to use the electrons to kick off the chlorine. We get our oxygen and whatever carbon was attached to it, right, plus HCl. And remember, this works because, in short, this attacks the base of the carbonyl, pushes the electrons up. We get this tetrahedral intermediate, but instead of being stuck there, what can happen is we push the electrons back down and we kick off the chlorine, right? And so we reform the carbonyl. So typically when you have an acid halide, you're going to keep that carbonyl, right, that we see in our product, and we're just going to exchange the alcohol portion minus the hydrogen, which we see here, for the group that was there. In this case it was the chlorine. Alright, so this is how we can take acid chlorides and make esters. Similarly, if we look at this anhydride, we're going to lose our carboxylic acid portion, right, minus a proton. And what happens is we're going to add the other half of it. So the base of the carbonyl is still our electrophilic site. So we're going to add the nitrogen here. So let's just draw the carbon chain on the other side of the carbonyl exactly as it is, just one carbon. And now the nitrogen is going to bind to that carbon site, and the carbon chain on the other side of the nitrogen is going to come along for the ride. So it's still going to be stuck to the nitrogen. So let's draw that. So there's 1, 2, 3 carbons. And what happens here is you keep one hydrogen. The other one can go with the portion that we lost. Right? So in this case, this was our leaving group, right? That was in the box over here. And so that's how we add nitrogens to anhydrides. And what we form now is our amide, right? So we've made this amide bond. And we could have done the same that we did with the acid chloride and made this bond. So any nucleophile can attack these esters, acid halides, anhydrides, and we're going to kick that other portion off and make that new bond with whatever our nucleophile is. Alright, let's take a look at another one. Now this one's a little bit tougher because we're still attacking the base of the carbonyl, but now we have a secondary nitrogen. Right, so our amine is a secondary one. We're still going to attack the same way, so let's keep the benzene ring. Remember, we typically don't do anything to the carbon groups on the other side of the carbonyl. Remember, for all these reactions, we're keeping our carbonyl, so let's just redraw that. And now, in place of the chlorine, we're going to start with our nitrogen. So let's draw that. And we're going to keep the two carbon groups already there. So on one side you have an ethyl, and on the other side you have a methyl. And remember, we lose one hydrogen, and we keep the two carbon chains. So on the right, it's ethyl, so that's what we have here. On the left is a methyl, that's what we have here. And then the hydrogen and the chlorine go together to make HCl. Now sometimes in these reactions you'll either put two equivalents amine or you'll put some triethylamine, and they're just there to help eat up the acid that's formed.